So Anurag, I want to hand it over to you to take it on. So this session is actually how, so blockchain is, there is a lot of talk about blockchain, but I think we need to understand the basics. So Anurag, please start from the basics because our viewers will have very basic, they would first want to know the basics and then go to the deep. So over to you. And the man can come in the discussion.
That's right. Yeah, because I could probably walk around close to there. So first of all, thanks a lot for having me here, Akram, and thank you very much for that warm introduction. And thank you all for being here in the second half. I know this is one of the most difficult sessions. I generally try to avoid this whenever I get slotted in conferences because, for obvious reasons. But again, I see a lot of people here, which is really interesting, and the fact that we're talking about not cryptocurrencies but more on blockchain. That is where the technology is. But of course, I'm going to be talking about cryptocurrencies as such, but very briefly, just to give you a context. As Akram was mentioning, this is PG Upadhyay, she's the CEO of the company. She's also my wife. She has 22 odd years of experience in the enterprise solution software, that kind of area. And as a company, we've been working together for now 7 years. In the blockchain space for more or less 4 years now. And last 1.5, 2 years at the intersection of blockchain and AI. That is an area which is where we have been heavily focusing because that is where we see a lot of synergy. And it's not just blockchain and AI, of course, that was the context for this presentation today. But it's also blockchain, AI, and IoT. So wherever that data is getting generated and then technicalities in terms of securing that data. So that is where some of these newer developments are happening. PP was pretty much, she just, I'm going out, this is my son. So Akram was requesting, that's how I'm here for this presentation. So I'm just leaving right after this presentation. So she had just come to drop off. And somehow she started here to sort of be with me. Thank you so much for sharing the data with me. You want to say anything?
Yeah, so basically our company is dealing with blockchain solution development. And obviously, blockchain and AI together can do a lot of wonders. So today, when Anurag is discussing this presentation, we have collectively made this presentation. And he'll be talking about where the blockchain and AI is converging, how together they will work, and what are the problems when they don't work together. So these are the things we'll be talking about today.
And I think what we're trying to do is, relatively longish presentation, 40 slides. This is probably one of those presentations which I generally don't try to give unless it's a workshop format. But because of all the things that Akram wanted me to cover, the presentation is relatively 40 slides. So more or less hour, 20 minutes or so. But what I do want is it should not be more of a lecture because that is how I thrive. Is I have a slide, you just ask me a question, I'm actually looking for clicker and see if it doesn't have here. So I'll walk right to the end and try and explain stuff. If you have any questions, please just stop. Right? Okay, so what are we going to talk about today? 3 things here. First is what is blockchain. Second is the convergence of blockchain and AI. And finally, look at a couple of use cases. Okay, let's move on. So first of all, I'm just trying to set the context here. So blockchain, Akram was talking more in terms of how people, at least my interactions here in India is that, blockchain and cryptocurrencies, for people they seem synonymous. It's one and the same thing. Obviously, that's not the case when you go to some of the other countries. And I'm hopeful that this is going to change in the next couple of years because it's a critical technology, not just for individuals, but for the country itself. And if you look here, I have put together some of the areas where there's already heavy work going on. Auto industry is a big one. This is in the coffee chains, like organic coffee. And I'm just saying organic coffee, and somebody was mentioning about a unicorn, $1 billion company. This is already $2 billion. Then Walmart is really heavily betting on this. And I'm just taking an example of Walmart. You take any big food chain, retailer internationally, there's been something or the other in blockchain. Healthcare is another big area, and pharma as well. So, especially in the supply chain, if I have to say that. Now, if you look at the numbers, sheer numbers, 2025, $175 billion is where blockchain is going to be. And compare that to AI, it's more or less in the same space. Like, and AI, of course, has been there for such a long time. It took off almost like now 10 years. But look at blockchain, it's already fast catching up, and the way it's laid is probably going to be taking over. And the reason why that's the case is because it has use cases almost every specific industry that you can think of. So let's get to what really is blockchain. So in the very simple terms, you can think of blockchain as a giant Google spreadsheet. A spreadsheet where you have transactions recorded. So very simply, that's what it is. But there are nuances to it. The first nuance comes in that you can go and have a look at it, but you cannot edit. To be able to edit, you need certain rights. So not everybody has permission to change records, but everybody can view it. So it's very transparent, first of all, but with limitations in terms of who can add new transactions or new details. Now, when I say transactions, it could be multiple things. It could be, of course, transferring digital money, which means maybe I'm transferring you a Bitcoin. That is one transaction. If I'm transferring you a file, if I'm storing a specific data, if I'm storing my information, everything is a transaction. It is converted into a specific hexadecimal format, like it is hashed using certain algorithms, and it always follows a specific format. And of course, I'm going to talk about it eventually in this presentation. But for the purposes of understanding, it is always fixed size, right? And it is arranged in blocks. So transactions, they, unlike a spreadsheet where you can just go and update a transaction. In this case, what happens is you wait for a certain number of transactions to be confirmed, and that block is added to the ledger, right? So it's not that every time there's a transaction, it just gets added, right? So there's a block of transactions, it waits for confirmation, and then it gets added. I hope I'm not rocking people's way here. And then these are linked. So these blocks are linked, and they're linked cryptographically. I'm going to talk about how they're actually linked at the back. So now let's get to another area which is very interesting. So we know traditional client-server model, how information is stored in client-server model. So the way it works is you have all these multiple devices which are sending information to a centralized server, right? And you have a ledger copy here. So the only way this ledger gets updated is by going through the central server, right? And this is like a big IBM mainframe sitting somewhere in the dark room, right? That's how it is. So the model is you have this central point, and then you have all these nodes contributing information here. But the entire single source of truth resides on that central data point, right? Now compared to blockchain, which is a peer-to-peer network, here what happens is, if there is a transaction, I'm going back to the definition of transaction, like it could be anything, digital cash, information about you, anything, right? So any of these nodes could initiate a transaction, and as soon as the transaction is initiated, it gets propagated into the entire system. So one of the nodes would do a transaction, it gets propagated, and then everybody has the same copy of the ledger, and the copy of the ledger gets updated to the new version of truth, right? Here there is just one version, here everybody has their own version, but everybody's version is always the same. So it's not that my version of truth is going to be different from yours. Everybody's version of truth is always same, right? So that's the beauty of the system, that everybody has the same ledger copy, and it's always updated. As soon as a transaction happens, it gets updated. Of course, there's a mechanism by which these transactions get updated, but there's always the case that everybody will have the same source. And so this is how the network looks like. There's no central point here, right? So these are all distributed. Now the beauty of this system compared to the one above is that imagine if you have the ability to break into the system on top. All you need to do is just somehow hack this system, and you brought the entire network down, right? Whereas in this case, maybe you're able to hack one or two, and these are not just 4 systems here, these are basically millions of devices globally. So even if you're able to hack a couple of these systems, it doesn't really matter, because what the network believes, which is basically the majority believes to be the truth, will always remain the truth. So if there are suspect nodes where certain fraudulent transactions have happened, it doesn't really matter, right? Does it make sense? Like, I mean, before we get to the next slide, any questions, anybody, or it's fine? Okay, so that basically gives blockchain the hack-proof ability, which is what people talk about. That to break into blockchain is really impossible. Of course, people are working on quantum computing, and then there are of course other things which in 10 years' time probably things are going to be different. But then again, in 10 years' time, who knows what blockchain is going to be, right? But today, as things stand, this is how the network works.
Can you explain what this ledger is like? For example, ledger will be my transactions and data. So other person also having that same ledger, I do.
Right. So ledger is basically that Google spreadsheet sort of thing which I mentioned in the previous slide, right? And on that, whatever transactions happen on the network, they're all recorded. And as soon as a new transaction happens somewhere in the network, the entire network has to first of all approve the transaction, that it is a ledger transaction between two ledger participants, and then that transaction gets recorded on the ledger. And as soon as the transaction gets recorded on the ledger, on one of them, it propagates throughout the network, and so everybody's copy of the ledger. And it's basically a database, right? So it's a database which just gets updated to the new version.
Has my transaction, it has other transactions also?
Yes, yes. So because it's a block of transactions, if you remember the last slide, where I said a block of transaction gets approved. So it could be, I'm sending you 2 Bitcoins, and I'm receiving 3 Bitcoins, maybe he's sending it to him. So these are like multiple transactions grouped together in a block, and then that block gets approved by the network.
And we can view the other transactions also?
Yes, yes. Everything is transparent, like I said. Everything is transparent. And there is, of course, a flip side to that. Like, for instance, imagine this is a banking network. And if you are able to view everything, then it's not really good, right? So again, there's another, there's a small slide where I just briefly talked about, I mean, like I said, it's a very complex topic to be covered in just 1 hour, but I'm still going to be giving snippets of other areas as well. So these are the two. So you can see there's a philosophical difference in terms of the architecture itself, how the two systems are designed, right?
So basically, if you talk about Ethereum, it just started with 7 MB something, and today it is 135 GB data. So whenever we try to create a node, so basically we download all that data in our computers. That is the kind of space it takes. That's how I become a node. So not every user needs to have that large amount of data. If I am the person who wants to approve or mine something, then I need the entire copy. But eventually, if I just want to look at the data, I will go to the blockchain and look at it. So I don't need to carry the entire copy for viewing it. So I need to carry the entire copy if I want to approve some of the transaction, if I want to mine something, so then I need it.
In the next slide where I talk about the approval process, which is where people who approve what transactions. So you remember I talked about everybody can view, but very few people can edit. And so what Preeti was talking about, those people who have edit rights, and those people who have edit rights need to have the entire network's copy on their system. And I remember, I think, and Preeti can of course tell me the exact numbers, but I think if you have to become a member of Bitcoin blockchain today, it probably takes between 7 to 10 days to download the entire updated network copy, and if it's Ethereum, probably 2 days, 3 days. How many days?
Yeah. No, I think Ethereum also takes 9 days. After
9 days.
It's a larger data.
So that's a big chunk of data sitting over there, right?
There is a reason behind doing this. And if you look at Wikipedia, all of us know Wikipedia. So if I want to change the data in the Wikipedia, I can simply edit it and add the text for it. But there's nobody who's verifying that information. So on the blockchain, when we have a copy of everything, it gets first approved before it gets committed to every machine. So we are aware that all the data that is there, that is coming on our machine, is a trusted data. Somebody is sitting there and approving it. It's not like Wikipedia, anybody can come and edit some information.
So now let's get to the actual stuff. So we talked about, at a very high level, what is blockchain. Then we saw how it's different from a traditional storage system. And now we're going to dive deep, and we're going to look into what exactly is in the block, right? And then what is this term blockchain all around? So the way it works is, I talked about multiple transactions, and they get processed in batches, and each batch is basically the block, and the block size is always fixed. like the transaction size. So imagine in this case, there are a couple of transactions going on at the same time they have been submitted. So this data pool here, transaction 1 to transaction 15, transaction 1 to transaction 15 is basically an unconfirmed transaction pool where all the transactions go for getting approved. So one of this is Alice is maybe sending 1 Bitcoin to Bob, right? So that is also one transaction, maybe that's transaction 4 or 5 or whatever. And this is how a block is going to be looking like. So the idea here is out of these 15 transactions, if this blockchain system has a block size of 5 transactions, so the entire network, right? The entire network has to go and pick up those 5 transactions, which are going to be part of the next block. And the way it works is not like, okay, randomly I'm going to go to something. There's a very complex mathematical algorithm which is running at the back end, where everything is time-stamped, everything is made sure that the new transactions which are going to be part of the block are not just the transactions which were submitted at the same time or in a specific order, because everything is time-stamped, everything is chronologically linked. Therefore, is actively involved in this process of approving, coming up with a new version of blockchain. So he's a miner because he also gets reward. So it's coming from the traditional mining space where you actually mine for gold or any other rare metal, right? So presumably Bitcoin is a rare thing. And then, like I said, the network verifies it and the transaction gets stored. So this is how it works. Imagine all this information, and we have finally picked up these 5 transactions, transaction 1 to transaction 5. And there's this blockchain, new block number 358. So that block number 358 is going to get appended to block number 357, which was the previous block, right? And as you can see here, all the information from inception till date is there. And the way it's there is because it is pointing to the hash of this address here, right? So the hash of this location is already there. So if you look at the hashing number here, and all the new transactions. So what this means here is block 358 is linked to block 357, which is then linked to 356 all the way till the Genesis block. So all of these are linked, and that is how this term blockchain changed. But there's also another fascinating thing here because it has information about all the previous transactions. So imagine if I were a malicious actor and I was trying to change the version of truth. From transaction 4, I said, no, you know what? Transaction 6 is what the new block should be, right? And I try to add it here, which is fine. I can do it on my system and try and see what I can do. But as you see, everything is linked. So I not only have to change my stuff here, I have to change stuff here, I have to change stuff here. I have to basically change every single information on the blockchain. That's first thing. I not only have to change it, I have to get the entire network to approve it, right? So these two things working together is practically impossible, and that is why. So when you say stakeholders, stakeholders is all
approving agencies.
Yes, there's no agency. So when you become part of the network, you are one of the approvers.
So if the approvers approve, then this is possible.
Yeah, if the approvers approve, then this is possible, and it's not just one or two approvers, the entire network, right? And the reason why it doesn't happen is for twofold. So if I am part of the Bitcoin network, I also have some of my Bitcoins. So there's a vested interest, first of all, to make sure that only legitimate transactions get recorded because my money is involved. I don't want a wrong, faulty information to get recorded there, and eventually it has to be reversed. So therefore, I act as a protector for my network. And of course, when I'm approving a network, approving a block, and I get rewarded for that. So I get Bitcoins for that. So those are the two reasons why nobody would ever do that. Hi.
So there is a lot of talk of using blockchain for voting.
Yeah.
So like you just tell briefly like how is it possible to?
Right. Again, the combination of technologies, which and it's a good question. I don't know if all of you followed what he was asking. So, sorry, what's your name?
Rajesh from Policy.
Okay, Rajesh from Policy Times. I think his question was, there's a lot of discussion about voting using blockchain. And yes, I mean, we were actually working on a use case for one of the European government agencies on developing a voting application for them. So we were looking at a POC for them right now. And the idea is more or less like this. Imagine there are, and the first stage, of course, is to test it out with the parliamentarians. And one of the problems which was identified was these. Oftentimes, you need to have a certain decorum to be able to pass bills, and because parliamentarians are not always present in the parliament, therefore some of these bills don't really get discussed, debated, or passed, or whatever you call it. And so the idea was is whether there is a way where all these parliamentarians can still vote on the bill without even being on the parliament. And so what we're trying to do is a certain identity-based verification, which is like a KYC, which is very robust, at least in the blockchain space now. It's being finessed over the last couple of years. And so using that, imagine maybe Lord Chamberlain sitting in his office or home somewhere, he logs into the system and he's able to see all the bills, and because he's using this blockchain protocol, everybody knows, yes, this is Lord Chamberlain, right? Because we have been verified in various ways. And so he goes and looks at all the bills which are there and decides to comment, approve, or whatever, and move the bill to the next stage, at least for the debate point of view. So that is where the POC is right now happening. Of course, the idea eventually is that once it moves from the parliamentarian stage and it is really successful, then actually open it for the electorate to be able to vote. I mean, probably you guys would know the numbers better, but I think for sure, I mean, going by the figures of people who actually go and vote, it's like 50% here in the country, of course for various reasons, but I also know a significant portion is because they're not able to go and vote right, in their hometown, they're not able to travel, so the vote gets lost. Right? So if the system was in place, the participation would obviously go up as well.
So that's like if you have heard about Amazon Go, so what they're generally doing is when they use a computer vision and a lot of IoT actuators and sensors, what they're doing actually is if you go into any shop, you purchase your product, it will list it out in your like wallet or something like this. These are all the products you have been already gathered in your bag. Okay. Once you move out from the shop, it's when the transaction will happen at the same time. So can we think like we can introduce this cryptocurrency over there or like a smart contract?
Yeah, smart contract basically again, I mean, if we have to store the information in a certain sense on, and to your question, yes, you can. Of course, it is always use case specific. Your use case seems very conducive for that. And not really cryptocurrency, I don't know. But smart contract is basically you have certain inputs coming in. It's a small program like a business logic, which says, okay, goods received and inspected and approved. If everything can be done digitally, as you were talking about computer vision, sensors, actuators, so all of that information is fed in. And then the account is linked to a certain bank account, centralized network. So the payment automatically gets processed. So one side there are inputs, on the other side there is output. So the smart contract is just this logic which decides, okay, based on these inputs, this is going to be my output. And my point is, this whole idea of smart contracts has been there now for 20 years in different forms of fashion. What blockchain has done is, using the underlying technology, adopted smart contracts. So smart contract is not an invention of blockchain, that's my point.
Actually, the group of companies are working on a technology called hyperledger and Fabric and Composer integrated together. So, like, will this smart contract very more deeply solved by these like technology like hyperledger and Fabric and Composer? By the conventional process, it is more evolved.
So Hyperledger has built-in smart contract functionality, right? It's called code base. And so all of these companies, wherever they're using Hyperledger Fabric or Hyperledger Composer, they would always use that functionality. It's inbuilt into the system. So the third one is security through cryptography, and I think cryptography, is being going on for World War II, Germany, and whatever, right? So cryptography has been there for a very long time. And then finally, network consensus. Again, like people coming together, voting, or doing whatever. And all of this is binded together using game theory. Again, game theory, John Nash won the Nobel for that, right? So again, it's been going on for ages. So if you look at this carefully, Distributed network. How many of you have ever used BitTorrent or Napster or anything?
Anurag, sorry to
Right.
can you just define these things, small things? Because many of the people were asking me that, we heard about cryptography or we read over it, but what does it mean? Like smart contracts, I think you have already explained what it is. So if you can define or give the definition or basic background of it, that'd be great. All the words that you're using.
Right. So So if you look at distributed networks, I think we talked about how the network is split between different nodes, right? Multiple, galaxy of nodes coming together. It's not just one node, which has a copy of the ledger. So, and I was trying to give you an example because I'm sure all of you have probably used BitTorrent or something similar, or at least have heard of them. So they're of course based on this technology, and they've been there for, 20 years, 25 years, 30 years, right? Smart contract, like I said, is this whole idea of building a business logic into a small program, and it's a self-executable program. The way it gets executed, certain inputs are there, like I see the goods are received in a certain condition, and it automatically creates an output which is just payment transfer. So now people don't have to chase for payments, now they don't have to send physical copies of invoices and bills and hope that the bills don't get displaced and actually get paid on time, because everything is a smart contract, everything is hard-coded on the system. So as soon as the system kicks in, these things happen automatically. Security through cryptography. So what I was saying is cryptography, as you all know, is this whole science where you use different ways of hiding information, right? You encode that information, encrypt that information. So it's used in cybersecurity quite a lot. All these SSLs that you probably use. These use encryption on your website. So again, cryptography is something which has been going on for, as I said, since World War II, which is when more or less things started on this. And network consensus, where the entire network comes together and votes. So the consensus, this whole idea is again been there for a long time. And game theory, of course, John Nash came up with this game theory, and this has been there. But the glue for all these things, of course, is the game theory, which is where people get rewarded, they get bitcoins for that once they approve a network, and therefore all of these things come together. But if you look carefully, all of these technologies, these individual technologies, have been there for at least 20, 25 years, or even more. So blockchain, basically if you dissect, it's not revolutionary, it's not innovative, but it is innovative in the fact that somebody had the genius to think through and put all these pieces together and come up with this architectural network. Right? So that is where this is different from anything else. But the basics have been there for a long time. So the first phase, which was Bitcoin 2008, had those 4 things which I talked about, right? And 2013, 14 is when Ethereum came along. So Ethereum was the first blockchain after the Bitcoin blockchain. So there was a gap of 5 years. So for 5 years, there was only one blockchain ecosystem, which is the Bitcoin ecosystem. And Bitcoin was meant purely for digital cash transfer. As you can see, the white paper said peer-to-peer digital money transfer. And I really invite you to read that paper. It's very interesting. Ethereum came along. It did 2 things. It added smart contracts, and then it added a functionality to be able to build applications on top of this blockchain network. And so what happened after that is that it suddenly opened up for general people, right? Because now you are able to build applications, you are able to use blockchain, you are able to play around with it, and you have to just get creative and see what application you can do, and that's what has been happening. So first, of course, was this crowdfunding or ICO. I don't know how many of you heard of it. So it was this: if you have a project and you want to raise funds, you do a crowdfunding campaign on this, and the community sees your project and votes. So that was the first application, but there have been like a number of applications. So that was the first thing, and then if you look at the next wave, which is where all the enterprises got along. So somebody talked about Hyperledger, Quorum, whatever, right? So this is where the enterprises came along, which is where the banks, financial institutions. Now, if you look at JP Morgan, they have come up with the JP Morgan coin. Facebook is coming up with their coins, right? So you suddenly see IBM, Microsoft, Oracles of the world. Everybody's coming up with a platform approach. So they're trying to build. The closest analogy would be that they're trying to build WordPress basic template, and you could just go and sort of play around and build your own application, right? Of course, the WordPress template itself to reach the WordPress stage is at least 5-7 years from now. But that is where the technology is with the enterprise blockchain, and they see a lot of value, and there is a lot of value. So if I look at the entire blockchain space, the most cutting-edge creative work is of course happening with the 20%, which is the startups, mid-sized companies. But the actual revenue which is getting generated is 80% is with these big companies. But they manage to get into banks, they're doing POCs, they're working with financial institutions, they're working with the Walmarts of the world, like I said. So that is where they started making money.
Could you
Right.
name some of these giants?
Yeah, IBM is a big one. IBM, Microsoft, Oracle, these are like big names in this industry.
Already?
Yes, yes.
Actually,
And I'll tell you, I mean, we were working, Preeti was the solution architect for, we talked about, what did we just say, this blockchain district thing. So the guys who were working on the project along with the Telangana government, they came up with a project called 1101. And 1101, this project again is working very closely with, what's the company? Mahindra Tech. They have
Tech Mahindra.
Tech Mahindra, yeah. Tech Mahindra. And so they were trying to build a complete blockchain ecosystem for the Indian government, focused on India. So she was the solution architect for that. We were working with the Microsoft guys. And when you look at what we are trying to do together collectively, it's just making sure that whatever business they lost to these startups and suddenly, you see for 7-8 years blockchain was there was no enterprise, right? So they clearly lost on the wave. So now what they want to do is be able to get into this market and quickly capture whatever they have lost. So that is what the approach is. Whether it's going to change, hopefully it should change, and it probably will. But that is how they're approaching this, like very quickly, how can we just go and get some chunk here and there, right?
okay. Anurag, a lot of people ask me, what is the difference between blockchain, like Bitcoin blockchain ecosystem and the Ethereum? So what are the basic differences when Ethereum came? So you said smart contract and DAPP are the ones.
Yes.
Added.
So this is what was the two functionalities what got added, and it's not just added. So you have the Bitcoin blockchain, and you just add few things. The guy Vitalik, he came up with a very fresh design. He was basically a developer at Bitcoin for years, and he saw the problems. So you were talking about the scalability problem. So he saw all those problems, and that is how he came up with this version of new blockchain. And so this new blockchain had, of course, those 4 original features. But it was a lighter version where transaction speed is faster. So for a transaction to get confirmed on Ethereum, it takes roughly 17 seconds. On Bitcoin, it takes about 10 minutes, right? So that's the quantum of difference, first of all. So he saw all of these problems, and then when the network load is going to go up, how these transaction speed is going to further get reduced. So based on that, he came up with this version, right? And he added smart contracts to make it more modular, where people could use it for not just transferring money, but for doing everything else. And then you use this functionality of distributed apps, where you could build applications on a distributed network, because you're traditionally you're building applications on a centralized application network. Now you're being able to build applications on a distributed network. So that is how the two changed. And when you look at the enterprise guys, they actually realized my information, if people are able to see, access, there's complete transparency. That's not what I want if I'm a financial institution or bank or whatever, right? So I need a system where I borrow some of these functionality, but my information is only visible to the parties who are involved. So maybe, for instance, a Citibank or Wells Fargo in the US and State Bank of India, there is a transaction between the two. So the entire world shouldn't know. They don't need to know anyway, right? And that is how the enterprise system came along, where it's just restricted, and of course, philosophical difference in terms of how you design the architecture. So that is how it's been evolving. And there's not a finished job yet. I mean, clearly there's a lot of work still to be done. It's probably going to take another 5 years. And that is probably one of my push, and especially when I talk in the Indian context is, and I'm going to talk about it, I don't want to sort of go ahead on that. Okay. So this is an illustrative example of how a blockchain might work. So you have a participant A, which might be somebody who's producing goods. Participant B is one who's taking those goods. And the way it works is you have all these insurers, regulators, auditors, banks on both sides, right? Before the good can be received and the guy gets paid. Whereas with blockchain, what happens is the ledger copy or the information is always updated. So everybody has the same version of truth at all times. So as soon as goods move from point A to point B, the banks can also see, regulators, auditors, everybody can see, and with the click of a button, you just approve it. So you don't have to wait for an inspector to go out and inspect goods. Again, it's not there in all the cases, but in some of the cases where there is a strong use case, this is already being implemented, right? So areas where this is possible today, and again, that's where others are working on, this is how simple it can become. With just a click of a button, you can actually move to the next stage. So a transaction which might take, approval transaction which might take a week or two, can now be done in less than an hour, depending on people's availability with a click of a button. So that is how simplified it gets.
Yes, actually I have a question.
Okay.
See, in blockchain technology, there is a hash function. And whenever we encrypt a block and then send for a transaction, then we used to decrypt it on the other side. So at the point of encryption and decryption, is there any possibility to, by any kind of method, by MITM attack or any kind of method, in hacking there are a lot of processing happens, like MITM attack if you are aware of. So is there any possibility to decrypt it at the time of sending the any kind of transaction?
So it follows, again, there's a lot of work going on that. There's circular cryptography, there's asymmetric cryptography, there's elliptical cryptography. So they're doing a lot of stuff in that area. Now there are zero knowledge proofs they're working on. So there's a lot of work going on. Till date, it's not possible. We have not seen a single case where people have been able to hack into at endpoints, which is what your question is, where at the endpoints they've been able to decrypt or encrypt. And the way it works is you get a public key from me, but the private key is sent through a very different route, right? If you look at the basic cryptography, it's probably sent over the same transmission network using the same more or less protocol. So anybody who's like a man in the middle, and if you're somehow able to look into the information, you are able to decrypt it. But now with these things which people are trying to follow, it's very different. And again, I would say 70% of the research in the blockchain space as on date is actually all going on in the cryptography side.
I've also heard the companies, those who are manufacturing ICs, now they are trying ICs, integrated circuits. Those they are trying to build small ICs over blockchain applications. Like Google recently been developed a small IC with the microelectronics on algorithms. Okay, different kinds of AI algorithms. Similarly, companies like microelectronics, those who are working, because when we talk about blockchain, it consumes a lot of our system hardware because it's decentralized. Like my GPU is also being used, your GPU is also being used while I'm mining or any kind of stuff. So rather than we'll be using the whole system, now they are trying to build some small integrated circuits that's having a probable algorithms what we trying to do for a particular application. So can you brief about?
I didn't get your question.
See, nowadays electronics company, integrated circuit companies, for a particular application, they are creating blockchain integrated circuits. We need to program a certain at point. Now, those small microcontroller, or you can say ICs, will work the same thing as we need to program in a system.
Right. So your question is how that is going to work?
Yeah.
So that's still going to be linked to the network. So it has to be linked to the network, and the information from that system is going to. So I don't remember now. Is it? I think the latest Samsung phones, whichever one is either is launched or going to be launched, and the same as Apple, they're coming up with this, blockchain-based processing and blockchain-based approval. So they're using already. So it's all part of that same ecosystem development that we're talking about. It's becoming more mainstream, and hopefully with costs coming down, it's going to be even more. Because I think sometimes the challenge is the transaction cost that you have to pay. So every time your transaction gets approved, you have to pay certain things to somebody, right? And so the transaction cost is where the people are trying to work around how they can minimize.
actually that brings me to my next question that I was wondering. If let's say I or a firm wants to develop a particular application for blockchain. As of today, how expensive is it? Let's say it's maybe for my city, for a public record system, I want to develop a certain application. Maybe for an insurance company, something like that.
Yeah.
So
How
like,
expensive? I think you get the question. I think I don't know. Maybe you want to take it. So I don't have an answer. Maybe you have it. So what? Sorry, what's your name?
I'm Monica Gupta.
Monica. Yeah. So Monica had a question where she's asking if you had to build a blockchain ground up. Any ballpark idea on how much that is going to cost?
See, it's around 12 to 13 months of a job to create a blockchain, because then you have your own hashing technique, everything needs to be done. And there should be a reason why we are creating another blockchain. Are we simply trying to replicate Ethereum, or what we are trying to do? There are a lot of formulas possible. We can use the existing open source code and do that. But if you want to develop from scratch down one blockchain, it would take around 12 to 13 months. 4 to 5 developers together.
Can be customized.
Oh, it's a custom and a raw blockchain. Then you decide what you want to
All
do.
transactions.
Yes, that's what 1101 was all about.
So we majorly develop in Solidity and other interfaces. Solidity is more preferable nowadays for blockchain development.
Yes, Solidity is about writing the contracts, writing the logic of the contracts.
It is expensive. I think coming back
Yes,
to your
it's
question
like,
was pricing.
yes, obviously the developers are very costly, and the time you see, so this is like that, and obviously the technical architect on top of it, a lot of strategy team that is sitting around to understand why we are doing this. Everything together makes it costly, but it's not like very, very costly we can't be doing, but at an enterprise level definitely it can be done.
I mean, based on what you're saying, I mean, if you look at that to develop in, US, Silicon Valley, you're probably looking at $5 to $10 million. And I think in India, you're probably looking less than $1 million. That is what I can say. Again, depending on the complexity, use case, because I think it's pretty good to have the use case clear, because that is where the logic comes in, that is where the consensus and everything else comes together. So if all that is done, and if it's a 12 to 13 month job, probably definitely less than $1 million or maybe even half a million.
Okay.
Yeah.
Yeah. So I have a question. We've been talking about that in this blockchain framework, every person would have its own copy, and any change being ensured data security by if somebody tries to change the data or one transaction data, so he has to make changes in all the
Yes.
blocks, right? So this is how you in a way maintain the data security, and that approval system is there. I want to understand, since for banks, for example, I have to implement this technology. I'm in a bank or a financial system. I don't want any of the transactions to be even known, seen by the network involved. So is there any other data security measures?
What's your answer actually?
Okay.
Let me explain.
Even before that, before he explains what public and private is, I would like to tell you that security is at 2 levels. One is nobody should be able to change it. So when you submit the information on the blockchain, nobody can change it. Only the append happens on blockchain. So for example, you have submitted a property information on the blockchain. Then you can't change that property information. But you can append the information on top of it, saying that this property is now sold to another person, now this belongs to another person. But
Of the other,
yes,
last one will
the last one will always remain there. So you cannot, alter the information from that perspective, you can append to it. The second is when you say propagation, when the data propagation happens across the network, it handles other part of the security, which is like when the central server all goes down, there is a disaster. So how do we control the disaster? So usually when the disaster companies are doing that, they have several copies of the data here and there, load balancers are there, that is how they manage. But with blockchain, when each node, is replicated on all systems, So whenever there is a disaster, automatically when the same node gets created again, the same data is replicated on the machine. So there is no disaster.
Mirrored.
So two things are addressed when we talk about security. But in terms of visibility, who can see what? That is a concern that came later on. Initially, blockchain was developed with the concept of transparency. I want to know who owns this property. You are giving me the papers. I don't know whether these are real or not. So I would rather trust the person who is giving me this paper, or maybe a central authority or regulatory body. If they say yes, this is the right paper, you trust it. Then I trust it. So in case of blockchain, everybody is like, we want transparency. That's how the whole concept came.
It's based on that.
Yeah. So, but then later on, when banks and financial institutions, these people are coming in and they were like, no. Some information needs to be hidden. You should be allowed only this. You should be allowed only that. Then came the concept of private blockchain.
Because the concept and the framework is very, very good, but the only thing is that when the transactions are happening and the applicability is huge, the potential is huge in the financial market, but the data security is a huge risk. So I wanted
So I think data security, what you're saying is that is how it addressed transparency and trust. Like the fact that you are able to trust the system because it is on the blockchain. That is a huge plus, because otherwise today you have to go to all sorts of intermediaries, clearing banks, like all these people in the middle who bring trust to the system. And of course they take money for that trust, right? Or banks for that matter. Like if I have to send money to you, the best way is to use a bank, because once I send money through my bank account, I know, it is going to land on the other side. And that is the trust. So imagine if you get the same level of trust without the banks involved. So I mean, charges are different from different places. I'll just give you a quick example. Remittance, overseas remittance into India, we are the biggest corridor, I think you probably know. Africa, so imagine if we do a lot of inbound transfers because I have a company in UK and US. So when she's doing a transaction from UK to India and she's doing it at the right time, the money lands in our account next day morning. So it's not even 8, 9, 10 hours. And we get a relatively good rate, right? We hardly get anything penalized. Compare that if somebody has to send money from California to somewhere in sub-Saharan Africa, it can take up to 7 to 10 days. And if somebody sends $10, the person on the receiving end only receives $7. It's all because, of course, there's a risk and you have to mitigate the risk, and therefore you need all these trusted bodies to give you that risk mitigation. And of course you charge for all of that, right? Imagine if you have this blockchain ecosystem where you don't really need all these trusted people, and therefore you don't really need them to take the cut. I mean, I'm not saying everybody is rich in our country, but if I have to compare on, let's say, I don't know, GDP basis, per capita, whatever, I mean, probably sub-Saharan Africa, right? They're already not having any money, and then you're taking 30% cut. And then you talk about all the social benefits, I don't know, whatever. So, I mean, don't even get me started there. But, I think that is where blockchain can really be, change the paradigm. That is how I see things. It brings trust into a platform or an ecosystem where you don't need to rely on trusted parties. And eventually it's going to be a mix of things. You have a hybrid version where you have some of the regulatory bodies involved in certain sense, like you had in the previous example, where regulators and auditors can look into, because they have access, but they don't really take a cut for that, right? So that is where this is sort of evolving. Then, coming back to this one, like, if you look at the top version, everybody can see everything. That is what is a public blockchain. So Bitcoin is pretty much like that. But if you look at Hyperledger, which is the enterprise version of Corda or Ethereum, this is how it looks like, where, imagine I am, Citibank or HSBC, and the other person is ICICI Bank, and we are all part of this network, like the SWIFT network. We are now part of this new blockchain network. So because we are part of the network, we are going to be designated by the bank or whoever to be able to access, and therefore my identity is revealed. And also there is a social quotient involved, right? Because maybe I'm the general manager or whatever. So, I'm not going to behave maliciously on this platform. And therefore, because of that assumption that I'm not going to behave maliciously, certain processes are shortcut, right? So the entire network now doesn't have to approve. It's only those 2 or 3 or 4 people who are looking at the information, they are approving it, because these are trusted people. And trust, of course, somebody has said, now you are the trusted person, we are going to trust you, right? Nothing wrong with that. Like I said, because identity is revealed, every transaction is still immutable. So if you try to, do anything otherwise, you are very quickly going to get caught. But because not everybody has to prove it, transaction speed goes up, system becomes very slick, and it works for the financial system and for all the enterprise applications where it's sensitive information. So businesses, for instance, smart contract. What is smart contract? Basically the business logic that if X comes, Y should happen. So if a smart contract is 100% transparent, which means your business model and the business logic is transparent, you don't want that. You don't want your competitors to know how you're running your business, how you're designing your pricing policy, what's your goods receipts policy, what's your inventory management policy. You don't want all of that the entire world to know, because once you put it on smart contract, it's out there on the web for everybody to see. So you don't want that to happen, right? So that is the difference, and I think therefore it makes sense in certain cases. In certain cases it doesn't. We talked about money transfer, remittances. Again, there are a lot of areas where it doesn't really make sense. So the idea is if my KYC is done once and my information is there somewhere, it's not just SBI, HSBC, Citibank, Bandhan Bank. Everybody can just tap into the system, look into that specific information and use it for themselves. So that is where some of these consortiums are coming into play, and consortiums are nothing but clusters of a specific industry organization. So if you are a mobility industry, the trucking industry, all the trucking organizations. If you are in the banking industry, all the banks, financial institutions are part of that network. So once you are part of that network, automatically your information gets transferred. And again, the privacy part is very nicely captured
Right,
here.
for civil scores.
Say that again?
Civil scores.
Civil score, of course, for India, but I think more importantly, the way they are trying to design these systems are, if there are 5 data points on me, and to do my KYC, you need 2 or 3. You will only have access to those 2 or 3, nothing else, and you're not able to see them. You just use it into your system, and upload it, and then you move on. So that is how the systems are getting designed.
That can be done.
Yeah.
How long will it take to summarize it?
How much time do you have? Because I don't know, I can just keep going, there's still a lot of material, but how much time do you have?
Actually, we have the other session now on artificial intelligence.
Right.
So maybe in like 5 to 10 minutes.
Right. Yeah, okay.
Focusing on the applications and some case studies.
I think I'm mostly done on the blockchain. I'll probably see if I need to look at the AI part, because that's another area. Maybe I can just talk about the intersection of blockchain and AI, basically 2 or 3 slides.
That would be great. So if you can connect AI and blockchain, then we'll go to AI.
Yeah.
Will it be helpful, like blockchain in this, like GST imports and credit, because nowadays, invoicing, placing on that, and the vendors is locking the, tax invoice. So can it be done that, for e-way bill and all?
So the way it's working, especially in the commerce, a couple of areas actually we were working with HSBC headquarters along with Accenture. Cross-border, especially trade finance is a big area. So all the trade finance we're trying to put on the blockchain using that. So we're working on the POC over there, and that is where all the supply chain issues of bill of lading, bill of exchange, all this getting lost, or the bank not really approving, some of these documents, and then you have to redo. The redo cost is like $200, $300. So all of these issues get sorted out once the information is on the blockchain and the network is on the blockchain, and that is where the consortia thing comes in. So if the ecosystem is on the blockchain, that's when you benefit. So it's basically a network effect. More people from the network are part of the network, that's when you are able to derive the maximum benefit. So basically, so far, because it started with Bitcoin and still has a lot of applications in financial institutions, financial industry. So finance is still a leading area, but then there are non-financial areas as well where a lot of work is going on. So this is what I was talking about. That's, I think you probably understand by now. When we need blockchain, then there are multiple parties, the parties are sharing, there is an intermediary who is adding information, right? So AI, I think there's already been a lot of discussion.
That is, we are starting the next session now.
Yes. And we're going to take 2 or 3 slides.
Actually, going on AI, since you will continue, I want to come back to my delegates now, because this seminar is all action oriented. So I want all of them have come with an objective to learn this. Now I just want their views that so far what have you learned new from what you already knew, and then how are you trying to adapt this discussion or adapt the outcomes of this discussion in your action.
Everybody in any industry without this technology is leather.
Right. So that's why I want to. I
So
will
no one
now
wants
let-
to be to last 26%. Everybody wants to.
So the last discussion is going to be AI, and we just had a discussion on IoT and then now blockchain. So I want, maybe if you can start from somewhere. So just give your background again, as we started in the morning, but maybe not your personal background, but the background of introducing this subject or understanding the subject, and then where from here and how from here you want to take this in your agenda. How are you going to add this in your agenda?
All of them in China. Google, Apple, Facebook, Microsoft, Tencent, Baidu, and which is the third one there, right? So together, collectively, they have all the data on us. What blockchain can do is, and again, we're not going to be having the time to get into the details here, but blockchain actually helps you democratize that data access. So you don't really get controlled by a corporation. With blockchain, that data is with everybody. So because it's a distributed network, it's a secure network, therefore everybody has access to it. And the way I talked about the Apple phone, the Samsung phone coming up with the blockchain processor chips, now what that's trying to do is, instead of your information going to a central server, Amazon server or Google server, now your machine can get trained locally. So if you're using an Apple Watch, all your information is getting generated here, and then it goes to a server where it gets stored, and then it gets trained, and then you are told what is good for you. Most of the time it is okay, not always perfect, but imagine this is the most authentic information, because here is all that data getting generated. And if you are able to train the model pretty much on the edge and use blockchain in the sense that it is secure, the challenge with centralized information systems is the hacking thing which we talked about, data leakages and all sorts of things. With blockchain, that never really happens. So it completely fits, right? So the challenges with AI and some of the issues with blockchain, when you put the two together, it becomes a very potent force. Yeah. Right? True. So one of the areas where this is being worked on is secure data sharing. So there are marketplaces like Google or Amazon marketplaces, right? So there are marketplaces where you could contribute your data. Your data is going to be 100% secure, and people are only going to be able to use your information. And it's going to be, you are a doctor, and it's really getting used in cancer research, where people, so imagine it's a clinical trial going on between a set of users, and I don't know how long it takes, 5 years, 10 years, right? And a set of users. But imagine if your research was to be opened up globally. People could contribute data to a specific location where their identity never gets revealed, but the progression or the way you're curtailing that growth of a specific illness, all that data gets to you, and so now you have a huge source of data to be able to come up with a better medicine or whatever, right? And that is where using blockchain and AI is happening. So you contribute your personal data, after having trained the system, realize that now enough information is there, it gets transmitted to a blockchain where your identity is never revealed, but then you are able to use that trained model to come up with outcomes. So this is just one example, but there are so many other areas where both of them are being brought together. Again, the last one is interesting here, coordinating between IoT devices, different IoT devices. How do you make sure? Hacking an IoT device, especially cheap one, is very easy. You get $2, $3, $4 worth of a sensor from China, and you very easily hack into and do stuff. That's where blockchain comes in. Providing the same level of security to an IoT device, which you would provide your enterprise network, is not feasible, economically not feasible. When the equipment itself is $2-3, right? But if you have a blockchain, it makes sure no fraudulent data just gets into the blockchain. So it's a very, very cheap and economical way of making sure data is there. I mean, these are areas where this is working on. I mean, I could get into this, and I'll probably, just move along and actually take you to one of the case studies which might help you get a sense. So food industry, some of these issues are there. Contaminated food, 1 in 10 falls sick. These are like global stats, okay? 420,000 people die annually from contaminated food consumption. Food waste, 1/3 of all food produced. Imagine if you were able to use some of that, how many hungry people on this planet would be fed, right? Identify and remove offending food, not the entire batch. So, especially in US and the developed countries, what happens if you identify offending food like a batch, the entire batch gets rejected. Because of course there is no way to identify, okay, what portion of that batch is not good for consumption. And then finally, food safety and quality standards globally, have all these trusted middle people who bring the assurance and trust, right? Imagine if you don't have to do that. Again, coming back to the question, you don't need people to bring in the trust if the system gives that trust, right? So, and these are two cases, like the real case. So, fish is caught off the seas of Japan, right, like this, and they are stored in a refrigerated container over there. Temperature is, roughly minus 20, 30, 40 degrees. These, expensive salmons, which gets tuna. But for some reason, there is a breakdown in the refrigerated unit. Okay, temperature goes up to 25 degrees, but people notice the problem. They are able to bring the temperature down. It gets to an importer's warehouse, where, and then subsequently through the food value chain, ends up at a retailer, and finally at a restaurant. It gets consumed by the consumer, and this is what exactly happens. 300 people on a single day fall sick consuming fish from Japan in California, right? The restaurant owner gets suspicious, couple of them. How come in a single night so many people fall sick? And that's when they start investigating. They are somehow able to find out this is what happened. But there is no record anywhere, right? Because it's all manual, so there's no record. I mean, if you manage to redo the system by the time it comes, you say, yeah, minus 40 degrees exactly, I'm going to take this produce, right? But this is what happened. And the challenge is there is no reliable way to make sure that the information is what it is supposed to. So if the condition of the food is supposed to be at a specific storage condition, if it deviates, there's no way for anybody, at least today, to identify, right? And so what's happening now is something like this. These are all, all these sophisticated sensors. Again, not very expensive sensors. So boats are equipped with that. Not only what fishes you are capturing, you have the live feed. You look at these cameras out here. They're just looking at capturing. They're looking at the water condition, the temperature, and all of that. And it gets stored here, right? And the entire sensor data is not just for the person, but it's visible to anybody in the supply chain. It goes to a wholesaler here. And everybody knows, like, if there is a fault, then of course you don't need to consume. But if there is no fault, then it's fit for consumption. Now, there are a couple of things what happens. So if the storage condition here changes, right? So if for whatever reason it goes up to minus 25 or plus 25, and systems are there now because it's on blockchain, there are alerts. So you have the bypass, system comes in, and it again starts to refrigerate the produce. But maybe for that half an hour, 45 minutes, with the temperature gone up, the best before the consumption date should actually come down if it is still fit for consumption. And those kind of things are possible using the smart contract. So once the system decides, okay, this much is the time elapsed, and therefore the shelf life should come down, and the smart contract is automatically going to change that in the system. right? And so that is the kind of thing which is happening now. So here there are two ways: traceability in repository, get submitted to the blockchain, and you can actually view them on the mobile app. So anybody who scans it, the QR code can see the entire history. And on top of that, if you have an AI layer, it actually decides what to do. Not only you are able to view, you are also able to decide. And with the smart contract, once the AI tells things, smart contract enforces things. So you are actually changing the entire business model. So I think that's mostly it. I don't think, you are a student, I can talk to you about what things.
How to
Yeah.
become a blockchain developer.
So this is the crypto world. A lot of people alluded to. There's a lot of push in terms of getting a quick valuation in your company in this domain, and people have been able to raise a lot of money. I think what we really need to do is to really look at key problems and try to solve a problem. So unless there's a solid business case, don't rush into you were trying to say, if I have to build a blockchain, I think my question to you would be, why do you really need a blockchain? What is your use case?
That is what we are discussing this morning, that
Yes.
ask the question or find the question first, or the challenge first, then talk about the technology.
Right. And for the first time, your point, how quickly there will be next unicorn, $1 billion. There are already people who are crypto millionaires, like 20, 21 years old, lots of money. And they don't really know what to do with that money. I just hope they use it to productive means. And these are people who know the technology, have benefited from it. And I think as a country, we really need to think how, other than that, we can look at. Some of the examples which I keep giving, Satya Nadella, Orange, New York, whoever. We have these global figures, Indian origin, but they're again out of India. We probably need that to change. We need to have those global people actually based right out of this country, which is where we are lacking. For various reasons. I can go on. This is my regular ground on this. We missed the hardware bus. Of course, whatever we are trying to do now, get some of the manufacturing back in the country. We're probably never going to beat China on that. Despite all the problems and Trumps of the world, things moving to different countries, but still nobody's coming and setting shops here in our country. So hardware is a long thing. We had a product opportunity. I think we missed that as well in a very big way. Blockchain, if you ask me honestly, we missed the first wave. There's a second wave which is again going on. The beauty with this technology is it's not a domain of a centralized authority or a country or a enterprise. It is distributed, and therefore there is this hope and also this opportunity for the country that we should seize the moment and actually try and do something about it. And think big, dream big, really, really. In this domain, you can do all of that with very little money. I would probably usually end it by saying, arise, awake, and stop not till the goal is reached. That is exactly what we should be aiming for, at least in this kind of area, where with very little investment, we have the ability and opportunity, because of the intellectual capital in the country, to be amongst the leaders in this industry. Thank you.
Thank you.